As 3I/ATLAS races toward the Sun, NASA just confirmed something no one expected. The interstellar comet has unleashed a powerful jet aimed straight at the Sun. Captured in new telescope images, the eruption spans over 10,000 kilometers and defies every known comet behavior. Scientists call it unprecedented. What's triggering this outburst? Solar heat or something far stranger? Let's dive right in. When NASA called the jet from 3I/ATLAS unprecedented, they meant it. The new images don't just show a comet behaving strangely. They show a visitor from another star system doing something we've never documented in human history, firing a 10,000-kilometer jet directly toward the Sun. And the timing could not be more extraordinary, right at the peak of solar maximum, the moment when the Sun becomes most volatile in its 11-year cycle. The Sun is now in turmoil, magnetic fields are twisting and flipping, sunspots are multiplying, and massive plasma eruptions are firing into space. In this chaos, most comets disintegrate long before they get this close. But 3I/ATLAS isn't most comets. As it races toward its closest approach, new solar observatory footage picked up something faint, a moving point of light cutting across the bright veil of the Sun. Independent astronomers reviewed the data, and its path matched predictions for 3I/ATLAS exactly. If verified, this would be the first time an interstellar object has been captured within a solar coronagraph, a direct visual record of an alien comet skimming our star's outer atmosphere. That alone is historic. But the deeper scientists look, the stranger it gets. Normally, sunlight pushes a comet's dust away, forming a tail that points away from the Sun. Yet telescopes now show 3I/ATLAS doing the opposite, blasting material toward it. The discovery came from the Tidy Observatory in Spain, which captured a series of long-exposure images showing a massive sunward jet. It's not random, it's structured, powerful, and continuous. Researchers suspect this behavior is caused by the comet's unusually heavy dust grains, particles so massive that sunlight can't push them back, combined with violent carbon dioxide outbursts. The result is what we see now. A reverse jet, a comet seemingly defying solar physics. Spectroscopic analysis confirmed the gas composition. CO2 dominates far more than in typical comets. That means 3I/ATLAS likely formed in a region much colder and darker than our solar system, a clue that this object was born under a completely different kind of star. This isn't just astronomy. It's a look into another planetary system's chemistry. Then something subtle but serious happened. The International Asteroid Warning Network, operating under the United Nations, issued an emergency planetary defense campaign. Not because 3I/ATLAS posed a threat, but because it was acting outside all expected parameters. For the first time, a global network of observatories coordinated to track an interstellar object in real time. Quietly, this became a test run for humanity's response to any future deep space intruder. And by coincidence, or maybe cosmic timing, two advanced spacecraft are now in a position to cross its path, ESA's Hera and NASA's Europa Clipper. Between late October and early November, both spacecraft may pass through the comet's ion tail, possibly collecting particles older than the Sun itself. If that happens, it will be the first direct encounter with interstellar matter in human history. That's not theory. That's measurable, trackable science happening right now. ESA also confirmed that its JUICE mission will attempt to observe 3I/ATLAS from November 2nd to 25th. But because JUICE is currently shielding its instruments with its giant antenna against solar heat, we won't get those results until 2026. In other words, some of the answers we're waiting for are literally 2 years away. This delay has led scientists, and yes, even skeptics, to ask bold questions. What if 3I/ATLAS carries complex material never seen before? What if its chemistry doesn't fit our models of comet formation at all? Harvard's Avi Loeb calls it a potential black swan event, a rare occurrence that reshapes how we see the universe. In his view, we should keep an open mind. Even if the comet is natural, it might still behave in ways that reveal hidden physics or chemical reactions triggered by solar energy. And if it isn't entirely natural, then it's the best chance we've ever had to find out. The closer scientists look, the less this comet behaves like any other. Spectral studies found more nickel than iron, an inversion never recorded before. Then NASA's Swift telescope detected water emission, not near the Sun, but when the comet was still 3 times farther from it than Earth. At that distance, comets should be inert blocks of ice. 3I/ATLAS was already alive, ejecting 40 kilograms of water every second. That's like firing a fire hose in space. Infrared analysis gave the answer. The coma, the glowing envelope around the nucleus, is filled with countless icy grains, each one acting like a tiny geyser. Sunlight hits them, they warm up, and they vent vapor even when the main body remains frozen. Instead of one big source of activity, 3I/ATLAS is a cloud of microengines, a self-sustaining storm of particles. That discovery redefines what a comet even is. It might not be a solid object at all, but a loose cluster of frozen debris, a kind of cosmic hive, changing shape as it travels through space. And this pattern fits perfectly with what we've seen before. Oumuamua had no tail at all. Borisov spewed carbon monoxide. 3I/ATLAS is jetting carbon dioxide and water at impossible distances. 3 interstellar visitors. 3 entirely different chemistries. Coincidence? Or evidence that every star system writes its own version of physics? If 3I/ATLAS's composition is dominated by CO2 and heavy carbon ices, it likely formed in a region where light barely reached, maybe in the far outer disk of its parent system. That makes it a time capsule, carrying information from a place that might no longer exist. Now it's entering our sun's domain, colliding with solar winds, and revealing how alien materials behave under human observation for the first time. This is not science fiction. It's a real-time experiment being run by nature itself. Could solar radiation be breaking apart compounds we've never catalogued? Could 3I/ATLAS be showing us how interstellar materials react when exposed to our star for the first time? Each new observation brings more clarity and more mystery. Here's what we know beyond doubt. 3I/ATLAS is active, energetic, and unstable. Its jets are releasing both carbon dioxide and water at extraordinary rates. It's moving through the most dangerous environment in the solar system and still holding together. Multiple space agencies are tracking it using mission-grade data, not speculation. And that's important because this story isn't about hype. It's about evidence. Every number, every image, every spectrum adds another piece to the puzzle of what happens when interstellar matter meets a living star. As 3I/ATLAS closes in on its perihelion, expected on October 29th, all eyes are watching. Will it break apart under solar heat, creating a cloud of alien dust? Or will it survive, swing around the sun, and escape back into the darkness, carrying traces of our solar wind, a piece of our star with it? Either outcome would be monumental. If it disintegrates, we'll witness the first recorded death of an interstellar comet near a star. If it survives, we'll have proof that alien matter can endure one of the harshest environments in the universe. And that, more than anything, could change how we see the cosmos, not as a distant spectacle, but as an active, connected system, constantly exchanging energy, dust, and stories between stars. Because 3I/ATLAS isn't just another comet. It's a reminder of how little we still know, and how much more there is to learn. So as 3I/ATLAS races toward its fiery encounter with the Sun, we're standing at the edge of something history has never seen. An interstellar object reacting to a solar storm at full force. Maybe it'll shatter into glowing fragments. Maybe it'll survive and vanish back into the dark. But either way, it's already rewriting our understanding of how alien matter behaves under a living star. What if this isn't just another comet, but a message from the galaxy itself, showing us how little we still know? The next few days will reveal everything: data, answers, maybe even new mysteries. So stay with us as we track what happens when the Sun meets something not from this solar system. If you enjoyed this deep dive, hit subscribe, drop your thoughts in the comments, and check out our next report on Galactic Breaking News, where we uncover what NASA's sensors just picked up after the jet fired. This story isn't ending. It's just beginning.